So in this section, we're going to talk about the future. So the future's here is what we're going to say. That the technology to do what we need to do is here. Can our equipment sitting in our facility handle what's coming and what we know is out there? Starting back again with our discontinued equipment, one of the things that we need to talk about when we're planning for the future is the availability of the components themselves. If we're planning a 5-year plan or even a 10-year plan, and we know already that our product should discontinue, then that certainly has to factor into our decisions. If we know we can't even get these parts now, well, 5 years down the road or 10 years down the road, that's only going to become more difficult. And when we do have to do this, what's the security around the supply chain? Do we trust who we're getting these from? Do we have a valid way to do it? Or are we putting ourselves at risk for the future by continuing and carrying discontinued parts in our plant? And then we get to the technological advances side of this. So like I said earlier, augmented reality might be futuristic. It might not be depending on your facility, but what you will need is data. So data is something that is absolutely going to be a part of the future of manufacturing. And that data is going to be used for many things. One will be executives taking a look at how the plant is doing overall, or even integrating additional supply chain pieces into your business to make quicker decisions and faster decisions. You're trying to optimize manufacturing as much as possible. What we're going to focus on today is that downtime piece of it. So in devices, the devices that we're actually using to build our parts might be variable frequency drives and the PLCs. A lot of the components used in manufacturing, they're getting smarter and smarter and smarter, and they're generating data. And with this data, we can collect it all and run analytics on our individual devices. So it's pretty common today that we have devices, whether it be in manufacturing or even at home, that can tell us there's a problem. A device can tell you, I broke, I had an issue, and even maybe here's what it is. You might get an error code that you can go and search the manual or look on the internet and understand, okay, this device broke and here's why. That's useful. But the issue is, at that point, you've already gone down. The device is already broken, the machine is already down, we've already lost production. What we're heading towards is devices telling us they're about to break. So instead of us going down to learn we have an issue, we're going to have a device give us a warning that I am about to break if action is not taken. What this allows us to do is, instead of going to a downtime event, we can actually schedule a repair. So we can schedule a repair when we have the resources we need, when maybe there was already going to be a scheduled outage or scheduled downtime, and we can address this issue before it's a 2 a.m. event where we're scrambling to find parts and scrambling to find the resources that we need. The last piece of this is, not only is the device going to tell us that it's going to fail, it's going to tell us what we can do to fix it. So imagine a device telling, okay, I'm heading towards a failure, but if you do this, it will mitigate the issue. We're heading to that direction where devices are going to be able to tell us these problems once we collect all of this data. This is absolutely something that is currently happening. We have devices that support this. We have devices meant to collect this data. But what we don't know right now is, with what we have in our facility, can it do it? So I'm going to go back to our PLC-5 here. PLC-5 set up with certain alarming conditions and monitored can tell you it had a problem. But is it going to be able to tell you that it's going to have a problem? Is it going to be able to prevent downtime for you? And if it can't, what is? What are we going to use for that PLC-5 system or legacy system? Not to pick on PLC-5, of the legacy system, what would we have to migrate to in order to get those diagnostics and be able to tell us what's going to happen to avoid downtime? What are we going to have to use for the security we need now for the unfortunate cyber environment we find ourselves in, where manufacturing plants are increasingly a target? And how do we know what we have to go to? What's the best path? I say easiest, not in a bad way, but we certainly want to make our migration as smooth and optimized as possible to try to reduce the amount of time and reduce the amount of costs we're going to use in a migration. So how do we know what we have to go to? We have a few choices here. The first, and I'll always recommend this, is ES&E has specialists that are built to do this. So ES&E has an automation team with various experts in many different fields: PLCs, HMIs, drives, vision, sensors. We have a team built to handle what is a customer going to do in a migration situation, or can they do what they want to do with the equipment they have if they have to migrate to a newer piece of equipment. What is that supposed to be? What's the best value for your specific application? We've also added this as an addition to an installed base evaluation. So if we take your installed base evaluation, go through the facility and tell you exactly what you have, what we can actually do is take it one piece. We looked earlier at reports and data, and those are powerful, but they're only powerful with what we do with them. So if we take those one step farther, we can actually build a migration plan. And what I'm showing here is just an example migration plan that this could look like. The important piece of this is we want to take that data from showing you numbers and values to steps. So the first important part is to understand, what does our equipment have to do? With where the plan is heading in the future, in the 5-year, 10-year plan, what is all of our equipment going to have to do? Is it going to have to be on Ethernet? That's very common with all the data collection we have now. Do we have company standards around hardware that we want to use or versions we want to use? Any other customer requests that are an important requirement that your machines have to meet going forward. We'll also include recommendations just based on what we find within those products. So what that looks like in a real example here is, if we were taking our installed base evaluation and highlighting an area with discontinued products, so 45% of the products in this line were discontinued, we take it a little farther and say, okay, here's what those products actually are. And this part so far is just another look at the installed base evaluation report. But one step past that is, does this meet our requirements? So if we said this had to be Ethernet capable, what this plan does, what this summary does, is it just looks at the results of the installed base evaluation and compares them to the requirements of your machines. So this, in this case, no, this is not Ethernet capable. It's a mix on active products. The processor's not active. Some of the I/O is, and the drives, some of the drives are. And then the recommendations. Okay, so what do we have to do? So this is where we rely on our automation team to come up with recommendations on how to move forward. What's the best way to do it? How critical is this? How do I prioritize it? And what do I do? So for example, a critical, very critical recommendation is the processor itself is no longer available. It's not Ethernet capable. It uses older software, and it's built on an obsolete platform. So it's going to give a recommended upgrade. And then there's moderate and minor. So it's going to help us prioritize, how critical is this upgrade? What are our choices? And this certainly leads to discussion. So that's one more example. Also, Rockwell actually has free tools that can help in this process as well. So if we had to do an upgrade and we wanted to plan a migration, there's a free tool called Integrated Architecture Builder. Within it, there are wizards to help us with this upgrade. Now, this is just going to be a bill of materials type function here. There is actually tools built available to do some of the logic conversion, but just focusing on the migration of the hardware itself. So what I'm showing here is, this is our example existing chassis. This is what we used to have. And we know exactly what we have because we've done an installed base evaluation. So we know what these part numbers are. We're not doing any guessing. We're not assuming here. If we actually populate this chassis with what is existing, then what the software is actually going to do is automatically give us recommended replacements. So it's giving me recommended replacements. It's including information for what's called a conversion kit in this example, where I can actually complete this upgrade without rewiring my entire system. What it does when I generate the hardware here is it gives me the same list of hardware in a view, and I can build a very large system doing this. And I can also generate the bill of materials. So this is all still in the free software. I can generate a bill of materials and understand budgetary pricing on a project. So for example, if I just look at a consolidated list of the parts I would need, budgetary pricing to move forward. And then on a larger scale project, we have Rockwell themselves has Modernization Services built to help with this process. Here's an example where Rockwell looked at a large fiber and yarn manufacturer. It was a high-risk environment, a lot of aging equipment, older drives, older PLCs, and they had a limited capital expense budget and extreme intolerance for downtime. It's not uncommon. A lot of customers don't like to go down, but there's still a risk factor. Some can absolutely not afford it based on the process, based on the cost. of downtime. So migration itself does have some risk associated. How can we complete the upgrades in as safe a manner as possible? So in this case, they actually utilized Rockwell engineers, and it was a long process. This is a 7-year project to phase migration over the entire plant using Rockwell engineers. But with doing that, they had a fixed cost. They had an understanding that was spread out over 7 years. They were reducing downtime in the process. And after the 7-year process, they had the migrated plant and the upgraded plant that they want. So this would typically be used in a larger application, but hopefully with this list, we can see that there's plenty of choices towards heading with the migration planning.